in 10th grade. And that is our good old friend Sohcahtoa. Yes! Yes! Sohcahtoa. We all remember Sohcahtoa. I could never spell that. Sorry to hear that. All right. Before we get into how I use it, I don't think your 10th grade teacher probably ever told you this. Do you actually know Sohcahtoa is a person? Did you know that? That Sohcahtoa is actually a person. It just happened to fall into a math topic. Sohcahtoa was Pocahontas' brother. I don't know if you guys have ever seen Pocahontas. She had a brother called Sohcahtoa. And it just happened to relate to math here. All right, so there you go. A little history lesson on top of math today. Sohcahtoa was Pocahontas' brother. How many of you guys believe me, and how many of you guys just think I'm full of crap right now? I guess you'll have to...
I'm a believer.
Are you? That Sohcahtoa is Pocahontas' brother?
Yep, I'm a believer.
Okay. Where was he in the movie then, Caroline? Where was he in the movie?
I have to go.
Okay. All right. You let me know how that goes. All right. All right, guys. If you remember Sohcahtoa, just let me go through what it meant real quick. Let's talk about SOH. The S stood for the sine function. The sine function. And you guys were allowed to use that function if you had the opposite side and the hypotenuse in the triangle. All right. If I had the hypotenuse and the opposite side, I used the sine function. I used C, cosine. I used cosine if I had the adjacent side and the hypotenuse. And then if I didn't have any of that, I'd probably rely on the T here for tangent, which stood for having the opposite side over the adjacent side. And I apologize with how quick I'm going to go through this. All right, but I feel like you guys have seen this enough that once you do an example or two, you'll be just like riding a bike. All right, so go ahead. Let's get a diagram down for part A. I got triangle ABC. Angle, they tell me angle C is the right angle. A and B, I told you guys yesterday, A and B can go anywhere, just as long as I know where that right angle is. Angle A, 37 degrees. AC is a length of 20. And now find AB to the nearest tenth. Got it. All right, quickly, before we solve this problem, I showed you guys a couple things yesterday. Why is what we did yesterday no good here? Why can't I use something we did yesterday? Well, let's go first. We did Pythag yesterday, Pythagorean theorem. Does everyone see why Pythag will not work? I don't know everything. I don't know something about all three triangles. So I wouldn't be able, all three sides, all three sides. So I'd go 20 squared plus, I don't know CB, so I couldn't plug anything in for B squared. And why I can't use a 30-60 or a 45-45 90 from yesterday? There's 37 degrees in there, right? 37 degrees, so automatically it's not one of those triangles. So now my last effort here is to use Sohcahtoa today. So first is, which one of the three do I use? Sine, cosine, or tangent? Here's how we'll figure it out. You always go from the acute, the angle less than 90. Never, ever go from the right angle. You always start with the angle that's less than 90 in the diagram, which is 37. Now I need your help. What's the 20 then? Is the 20 opposite? Is it adjacent? Or is it the hypotenuse in the diagram? What is the 20? Is it opposite the 37, next to it? Or is it the hypotenuse in the diagram? 20. Can you tell me here? Oh, 10. Way to start off the day.
Yeah.
Oh, Caroline, I should have known that by heart. Go ahead, Caroline. The 20, is it opposite the 37, next to it, or the hypotenuse in the diagram?
It's adjacent.
Adjacent, next to it. So here's what I like to do. You don't have to do this, but it keeps everything in track for me. I put a little A right next to the 20 that tells me that's adjacent. If you want to do that, that's fine. The other side is X. So now I'm down to, is it opposite 37 or is it the hypotenuse in the diagram? Here you go, 8. Colin, what is it in the diagram?
The x?
Yeah, is it opposite the 30? It's the hypotenuse. Thank you. So again, just like I did for adjacent, I put a little h next to it. So you have A and you have H, adjacent hypotenuse. Look at Sohcahtoa right now, everybody. Look at Sohcahtoa. Which one of the three am I supposed to use if I have the adjacent and the hypotenuse side? I have adjacent and hypotenuse, so which one of the three should I be using now? Let's go. Yeah, there we go. Anna, which one should I be using?
Cosine.
Cosine, good. So we've said you got to use cosine. So let's set up an equation to solve. Anna said use cosine. Remember, I don't write the full word cosine. I just write COS. Please don't say cos. Don't be an embarrassment to the math community. All right, it's cosine, just abbreviated COS. So Anna said use cosine. Got it? Cosine. Now I need an angle next to it. What angle did we work with in the problem? 37 degrees. So we're going to say the cosine of 37 is equal to adjacent over hypotenuse. Okay, the cosine of 37 is equal to the adjacent side, we labeled 20, over the hypotenuse. Colin told us that was x. And there's your equation we're going to solve. Ready? Oh, how do you solve it? Oh boy, how do I solve this? Jeez. All right, well, please remember, everybody, that cosine of 37 is still over 1. And now you have a proportion. Probably back in your algebra days, you solved it cross multiplying. So that's what you can do here. Go ahead and cross multiply. So I get 20 on one side equals, cross multiply on the other side, cosine of 37 times that x. So that's what it looks like after I cross multiply. All right, it said we're solving for x, so how do I get cosine 37 out of there? If anybody wants to chime in, go ahead. How can I get cosine of 37 out of there and x by itself?
Divide by 37.
No. Wait, hey, if I divide by 37, that just gets rid of the 37s, and I still have cosine there. I got to get rid of all of it. So not just 37, but
Cosine 37.
Cosine 37. That's an actual number stored in your calculator. Okay, everybody, not just 37, cosine 37. So I'll get x equals, and now it's up to your calculator. This is all calculator now from here. So I go to my calculator. I always like to do a fraction template. It's not needed, but I like to do a fraction template. 20 over, you guys have your cosine button, 37. And hopefully everyone's in degree mode and we all get about 25 and change if you're in degree mode. All right. What the rounding directions say? Nearest tenth. So what do we go? 25.0 because the 4 doesn't round it up. So 25.0. Old school days, right? Old school. You did a bunch of those. Questions there, guys? Anything? Okay, I'm just going to warn you guys to mentally prepare for part B. This one's going to be a long one, even though it doesn't look like much. All right, the algebra is pretty heavy here at the end, so just be mentally prepared for that. Find the exact value of tangent of angle A. Tangent of angle A. So there's no degree measures here. It just wants me to go to angle A and tell you what it's equal to as far as tangent goes. Tangent, everybody. Tangent of angle A. So what sides do I need here for tangent of A? We'll go up to Sohcahtoa. Tangent is opposite over adjacent, right? Opposite over adjacent. All right, I'm going to ask somebody now. If I'm doing angle A, if I'm going from angle A, what's the opposite side and what's the adjacent side to angle A? So everyone look at the diagram. Angle A, what's opposite and what's adjacent to it? You got this. 9 spot. Hunter, here we go, boss. What's opposite angle A?
5.
Yep. And how about the side adjacent?
Square root 75.
Yep. All right. So I think when you guys go to delta math here in a few minutes, I think it says like round your answer to the nearest 10th or 100th. You guys would just go to your calculator and do 5 over radical 75 and round it. All right. But unfortunately, our directions aren't that easy, right? It's simplest radical form. So this is where it gets kind of heavy right now. So buckle up. What's the problem with my answer right now? You guys that were in class yesterday, what's the problem with my answer? Why can I not leave it 5 over radical 75?
There's a radical on.
Can I not have a radical in the denominator? Correct. I cannot have a radical 75 down there. So to get rid of it, I know we only did one of these. Anybody remember to get rid of radical 75, what I need to do?
You multiply the top and the bottom by the radical 75.
God, you guys are good. Man. Got lucky this year. Got a decent group. Some of you. Don't think you're all included there yet. Still got to earn it from me. Yep, multiply top and bottom by radical 75. All right, so how does that change everything now? Well, on top, you'll have 5 times radical 75. And what about on the bottom? What did we find yesterday? A radical times itself. I had you guys do it in your calculator. Radical 75 times radical 75 will just be
75.
Yep, the number underneath. Good, the number underneath. Good, so good job. We got the radical out of there. What's still not good yet? We're still not done. Why not? Look at my answer right now. What's still the problem? There's still something we can do here, kids.
Can't the radical 75 be reduced?
It can't, not yet. Caroline, awesome. Yes, it is. I'm not looking to do that right now. I'm looking to do that in the next step. So I'll get back to you then. Okay? I'm looking at the 5 and the 75. 5 on top, 75 on the bottom. Doesn't 5 go into 75? 15 times. So I can keep going with that. Radical 75 over 15. I can reduce that. And I told you guys to buckle up because we're not done yet. Caroline, go ahead. Tell everyone once again what we still can do to radical 75.
Well, 25 goes into it.
We're just going to break it down. Just say breaking it down. I don't want you to actually
break it down.
We can break it down. All right, 75 can be broken down. And we didn't get to this yesterday because none of the radicals could be broken down, but now we can. I need a perfect square that goes into 75. A perfect square. Don't say anything, anybody. A perfect square. Remember, if you need the list of perfect squares, everyone has their calculator ready. Go to y equals, and you type in x squared in y1, x squared, and then go to your table, and then there's your list of perfect squares. So do any of those go into 75? You're darn right they do. One of them does. 25? 25? So 25 under 1. What should go underneath the other radical? You tell what 25 times what will give me 75 back?
3.
Yep. Over 15. That's how you break down that radical. Find a perfect square that goes into it. All right, let's keep going. Square root of 25 is 5. Radical 3. So all I did was take the square root of 25, and it's 5. All over 15. You ready to go on to the next problem or no? Come on. Go on to the next problem or something you can still do.
You can do it.
Yeah. Can one.
No, go ahead, Ella.
Oh, that's cute. That's cute.
You can simplify it more.
You can. Yep, that was cute, ladies. Very nice job. 5 over 15 can be reduced to one final answer. Jeez. 5 over 15. Radical 3 over 5. 5 goes in the, 5. What am I doing? One job. 3. 5 in the 15 goes 3 times. Whew. Sorry, guys. But I got to bring you to this level. I'm not afraid to do these tough problems with you. Not afraid. Questions there? Whew. You guys need a breather, a stretch after that one? Jeez. All right. I got 3 more problems, and then we're calling it a day, even though there's 4 left. 3 problems. All right, exact value of cosine A and sine A. Oh, this guy, simplest radical form again. All right, let's start. Cosine A. Go from angle A. Look at Sohcahtoa. Look at Sohcahtoa. Figure out what cosine is. What over what? Cosine, adjacent over hypotenuse. Okay, angle A, give me it. Adjacent and hypotenuse for angle A. Woo, top, Bassett. Here we go, brother.
Square root of 72 over 9.
Good job. Square root of 72 is the adjacent side. 9's my hypotenuse. Well, I don't have a radical in the denominator. That's a good sign. Do you think I can do anything to 72? Look at your perfect squares on your calculator. Go ahead. Look at your perfect squares. See if there's a perfect square that goes into 72. The biggest one. The biggest one. Any of these bad boys go into 72 evenly? I'll settle down, and I want to teach. You guys are going through, and you probably hit 9. 9 goes into 72, but it's got to be bigger, the biggest one. All right, so I'm going to tell you, keep going. There's a bigger one than 9 here. Anybody come across it? Bigger than 9 that goes into 72.
Wouldn't it be 36?
Thank you, 36. So radical 36 times 2. All right. Radical 36 times radical 2. Finish it now. Square root of 36. 6. Radical 2 over 9. I guess. Oh, thank you very much.
That's your kids.
Yeah, I will. Yeah, I'll give it to them. Yeah. I'm good. Thanks. That'd throw off my whole day. 6 radical 2 over 9. Anybody see what we can do there? 6 over 9. Reduce. And I'd apologize, but I'm not. We should be able to do this stuff. So what am I doing? Come on. There we go. 6 over 9 reduces down to 2/3. So final answer here, 2 radical 2 over 3. 6/9 went to 2/3. That's where that came from. And then it said, this one will go quicker. It said, find cosine A, now find sine A. According to Sohcahtoa, what's sine equal to? What sides do I need here? There we go. Ella, here you go. Now you can show off. Sine is what 2 sides?
Opposite and hypotenuse.
Good. This will go quick, guys. Everyone take a look at angle A and give me the opposite and hypotenuse from angle A now.
The opposite.
Oh, okay. Never mind. I don't need to call on your classmates, Ella. Just keep showing off. Go ahead. Sorry.
Oh, sorry.
Yeah, but it's Ella's moment, everyone.
No.
Go ahead.
The opposite is 3 and the hypotenuse is 9.
There you go. You good. Lucky you got that right. I would have been all over you for that one. 3 over 9, everyone. Good? The only thing I want to do is try to reduce that sucker, which I can do 1/3. No radicals. Yay, no radicals. Oh, whew, I'm sweating already. Everyone all right? Part D? You guys remember from your geometry days, angle of elevation? Angle of elevation. There was two types, elevation and anybody remember the other one? Or you can just cheat and look ahead in your notes. Elevation and depression. Okay, elevation. Draw yourself a right triangle. I got a person standing, casting a shadow. All right, let's get the numbers down and I'll tell you where this angle is. So we got a student 170 centimeters tall. I think we all agree that this right here, this side of the triangle has to be the student if he's 170 meters tall, standing up. Here's the part that drives me nuts, and I don't know where kids get this. His shadow is 170 centimeters long. On a nice, bright, sunny day, kids, where's your shadow located? Where's
The
your
ground.
on the ground? Has anybody walked past somebody else on a sunny day and their shadow is beaming off their forehead to the ground? Me neither. All right, I'd like to see that person if you've ever met one. Why do I ask you that? Because the shadows are on the ground. They're not beaming off your forehead down. Okay? So there's my triangle. Now, where is this angle of elevation located? Elevation, ground looking up. From the ground looking up. So angle of elevation will always be this bottom angle of the right triangle. Okay, that's the angle we're trying to find right now. Elevation, ground looking up. Ground looking up. All right, how do we find it? All right, here we go. I'm going to use the same rules I used for the first problem today. I go from the angle that I'm given, the one angle that's not the right angle. So in this case, it's X. So I'm going from X. What are the 170s? Opposite, hypotenuse, adjacent. What are they? What are both 170s here? Oh, here we go. Dan, let's go to the kid's height. This 170 of the vertical line, the kid's height. Is that adjacent, opposite, or the hypotenuse to X?
That's adjacent. To X? No, that's opposite.
That's opposite right here. Everybody agree? What about his shadow, Dan? That's what? Well, the one on the...
His shadow would be... Wouldn't that be adjacent?
That would be adjacent. Good. The hypotenuse is not labeled here. So go to Sohcahtoa, everyone. What do I use with O and A? Boom. Here we go. Anna, twice in one day. There we go. What do I use with O and A? Sorry to cut you off again. One more time.
Tangent.
Tangent. Thank you. So everyone ready? Anna says use tangent. Now remember in problem number 1, we wrote tangent of the angle we're going from. Same thing. Tangent, what angle are we going from? X. So tangent of X equals, now in this problem you can't go wrong at all, but it's opposite over adjacent. Opposite 170 over adjacent 170. All right? Everyone all right? Okay, now, this is going to be a little different to solve this. I know in problem number 1, we cross-multiplied. All right? I can't do that here, though. All right? Because if I cross-multiply it, it's going to bring me to a place I'm going to get stuck in. Anytime you need to solve for an angle in Sohcahtoa, everyone look at your calculator right now. Do you see sine to the -1, cosine to the -1, and tangent to the -1? Anytime you need an angle in Sohcahtoa, those are where I'm going to. It's called the inverse of sine, cosine, and tangent. So to solve this one, no cross-multiplying. No cross-multiplying when I need an angle. Instead, I'm going to go to my calculator and do inverse tangent, tangent to the -1, and plug in my fraction, 170 over 170. That's only if I need to find an angle. If you find a side, go ahead and cross-multiply. But finding an angle, I need to do the inverse button on my calculator. So everyone go ahead. Second tangent. And then it'll ask you to plug in your fraction, 170 over 170. And it should give you the degree measure for x back. And you guys getting out 45 degrees? 45 degrees. Only for finding angles. If I ask you to find a side length, go ahead and cross multiply. But angles, just got to use the inverse button. We okay for one last problem? And then you're on to delta math. All right, that's elevation. Ground up, that's elevation. We also have depression, which is now you're on the top of the building looking down at somebody. All right, you're now standing on top looking down. So we have a lighthouse here. Lighthouse, we good? That's pretty good. Not gonna lie. All right, we got the lighthouse. It is 190 feet high, so can we put the 190 where it should go? 190 feet high. It's like its height, 190 feet high. All right, the angle of depression is 34. Now here's where kids get confused because they think, oh, I'm standing up, I'm looking down. It should just be the other angle right here, 34 degrees. And it is not. It is not. That is not your depression angle. Your depression angle is actually outside the triangle. If you remember this from your geometry days, if I draw a horizontal line across right now, this angle right here, 34, is your angle of depression. That's my angle of depression. All right, it is outside the triangle, depression. On top, but outside. And we are finding the distance from the boat to the foot of the lighthouse. Oh, we got a boat here. Oh, you want to do the boat too? Sure, here you go. Little sail for it. There you go, boat. Or maybe a banana with a golf club in it, whatever you want to call it. All right, the distance from the boat to the foot, foot of the lighthouse, the bottom. So this is where we're finding right there. The boat to the bottom of the lighthouse. All right, everyone, all right. Look at that setup, by the way. That's like Van Gogh type stuff right there. Unbelievable. All right, anyway. I got a problem, guys, and I need your help. I cannot use the 34. I can only use angles inside the triangle to tell you what's adjacent, hypotenuse, and opposite. I can't use that 34 where it is. Is there any way you guys can help me use the 34 to actually maybe get an angle inside the triangle so I can use it? I see some shaking of heads. How can I use 34 to get another angle?
You can just do
90
minus 34.
Would you say 90?
90 minus 34.
Look at you, boss. Nice job. Yes. Here's what Colin is saying. Take a look. He knows this is a right angle right here, 90 degrees. So he's saying take 34, subtract it from 90, and you'll get your angle of 56. All right, everyone see how he got to 56. They add up to 90. Now tell me what's adjacent, hypotenuse, and opposite. Here we go. Let's finish this off strong. Oh, 2. Oh, Isaiah. Hi, Isaiah.
Hey, give me a sec.
No, I haven't even asked a question yet. You're going from 56 now, Isaiah. Always from the angle that's not 90. What's the x, the side we need to find? Is that opposite, adjacent, or the hypotenuse in the diagram for 56?
Opposite.
Opposite. So I'm going to put an O there. And then how about the 190? All you got is hypotenuse and adjacent left to 56.
Adjacent.
That's adjacent. Good job. So which one of the three now can I use with O and A, everybody? O and A I have. What can I use? Oh, there we go. Sophia, which one can I use with O and A out of the three?
Tangent.
Good job. So everyone ready? Tangent of the angle I went from, 56, equals the opposite side, x, over the adjacent side, 190. And is this a side or an angle? It's a side, right? So cross multiply. Angles are only when I do the inverse button. So over 1, go ahead, cross multiply. On one side, you get x. On the other side, 190 times tangent of 56. And that's in your calculator. That is in your calculator. 190 times tangent 56. What does that see? 190. Okay. 200. What's the directions? Nearest foot. So that boat is, come on. 282 feet away. All right. Anybody not get 282? If you did, just real quick, if you do tangent of 56 first, make sure you close the parenthesis before you multiply it by 190 if you didn't get that answer. All right. Okay, you guys know where you're going now. You got the assignment at the bottom of that page. It's fine. We're not doing the last one. Go ahead. See how many of these you can get done until you get 100. And then just ask, if you cannot get one of the questions, just ask me. I'll work you through it. Whew. It's getting serious today.
When it asks for ratio, is that
That's
like a
opposite over adjacent. That's what it's at. What's the fraction you make, Caroline? Okay.
okay?
Yep. Good question. Okay, guys, just remember that test on Tuesday. It's going to be all online. You guys have a great weekend. Nothing stronger than ginger ale. And I should probably add now, mask up. All right, so we can get back together soon. Have a good one, guys. Take care. Let me know if you got questions.
Thank you.
Thanks, guys.